You are saying router 10 will receive external prefixes but not will not receive these 10 prefixes and 80 prefixes. Okay, I have removed the EAGRP S number 10 configuration. Now ospf is already running, so let me enable ospf area 2 on f0/0 IP ospf 1 area 2. Earlier this router was ESBR router. Now so IP protocol include why this router is ESBR, guys? Boundary router, clear IP ospf process, and so IP protocol. Now you can see, and this router is in which area? NSSA area, right? So I am going to remove the NSSA configuration as well from this router. Say router ospf process 1 do so run section ospf. Done. Say no to this command. And now everything looks fine here. Done. On router number 8 also, see this time in this area, in area 1 I am allowing all LSAs, LSA 3, LSA 5, LSA 4. So router ospf process 1 and do so run section ospf, do so run section ospf, no to this command. Stub area, say no to this command. Now ospf neighborship will come up between router 8 and router 9. So IP ospf neighbor, so IP ospf neighbor, so IP ospf interface brief f1/1 f1/0 ospf is enabled on router number 9. So IP ospf interface brief ospf is enabled on both interfaces, and so IP protocol, and so IP ospf neighbor. Now how you are going to troubleshoot it? There's no ospf neighborship between router 8 and router 9. Tell me, how will you troubleshoot it? So run section ospf. Oh, this router is still NSSA. Router ospf 1 and no to this command and do so run section ospf. Now you can see we have ospf neighborship here, correct guys? I have to do same thing on router number 6 and on router number 7 also. These are my ABR routers, and I think these are stub router, stub area. Area 1 is stub area on these routers. So run section ospf NSSA router ospf 1 and no to this command and no area 1 and SSA. Do so history, and I am going to run same command on router number 6 also. Done. Just wait for some time. It will form neighborship between router 6 and router 8. Yes. So IP ospf neighbor. Done. Now on router number 8, let me check again the neighborship. So IP ospf. So IP ospf neighbor. Correct. And so IP ospf database. Now you can see all LSAs are there. LSA 1 of area 1, LSA 3 of area 1, LSA 4 and LSA 5. Done. It will advertise to router number 9. So IP ospf database. On router number 9 also you can see database is exactly same. Correct. Correct, guys. Can I move? Now I am going to form ospf neighborship between router 9 and router number 10. So on router number 9, I think I have already enabled ospf on both interfaces. So IP ospf interface brief. Yes, ospf is enabled, and one interface is in area 1, one interface is in area 2. Now let me access router 10. Config T, no router EAGRPS number 20 and router ospf process 1. Router ID 10.10.10.10 and interface F0/0 IP ospf network point to point and IP ospf 1 area 2. Then interface range loopback 1 to 4 and IP ospf 1 area 2 and IP ospf network. So IP ospf interface brief. Done, guys. So IP ospf neighbor. Fine. On router number 9, one more thing I need to verify here. So run or so IP ospf interface F0/0 include network type. Network type is broadcast here. Let me correct it. Interface F0/0 IP ospf network point to point. Done. Now see on router number 10. Yes. Only one ospf. So IP protocol. Only ospf. Routing protocol is ospf 1. Router ID and this router is in normal area. ospf is enabled on these all interfaces. Guys, passive configuration is same. Like if you will debug here ospf, so I debug IP ospf hello. So you will see this router is sending hello message from their loopback interfaces as well, right? So stop hello message on the loopback interfaces. What we can do, we can configure passive interface. Okay, by the way, it is here not sending from the loopback, but from the LAN interface it will send. Do one all. Now issue is so IP ospf database. Here you can see the database. We have all LSA 5. As you know, LSA 5 can cross the area, and for LSA 5 we don't need ABR or ASBR here between area 1 and area 2, right? So we have all LSA 5. Then we have router LSA of this area only, router LSA of area 2 only. Apart from these two types of LSA, you can see there is no any LSA 4, LSA 3, right? Now question is, can I ping to 20 means partner network 1, ping 20.1.1.0 network, and source 110.1.1.1 will ping work? Ping will not work. Now one question to you, tell me router number 8 for now, right, for this default configuration, will router have these routes, guys? Will router 8 have these routes? If no, then tell me why. Yes, correct. Router 10, these routers in area 2 will only generate LSA 1. So router 10 will share their LSA 1 to router number 9, and LSA 1 cannot cross the area. Router 9 have two neighbor. One is router 10 and other one is router 8. But router 8 is in different area. Router 10 is in different area. Both neighbor are in different area, right? So for inter-area communication, this router should generate LSA 3. But which router can generate LSA 3? Only ABR router, right? But this router is not ABR now. So that's why here you can check first of all on router number 10, so IP ospf database, here the router LSA of router 10, and so IP ospf database router LSA, then 10.10.10.10 10.10.10.10 done. It have include all loopback interfaces in their LSA 1, and now it is this router is going to advertise it with their neighbor with means router number 9. So router number 9, so IP ospf database, so IP ospf database. Yes, see on the router number 9 in area 2, this is router LSA in area 1. Let me show you the router LSA in area 2. Yes, here is the router LSA of area 2. How many router LSAs are there? 2. One of router 9 and one of router 10. But this router number 9 is not going to advertise it with router number 8 with their neighbor. The reason, so IP protocol, this router is, so IP protocol, this router is not ABR router. So on router number 8 you can verify the database, so IP ospf database. These are router LSA of area 1. These are summary LSA, LSA 3 of area 1. These are LSA 4 of area 1 and LSA 5. Correct? Is there any router LSA of area 2? No. Right? There is no any LSA 1 of area 2. So can I create one loopback here on router number 9 and I can then advertise that loopback in area 0? Will router 9 become ABR router then? Let me try. Interface loopback 1, IP address 9.9.9.9 255.255.255.255 and IP ospf 1 area 0. So IP ospf interface brief. Now you can see ospf is enabled on loopback 1 and in area 0. So IP protocol. This router is, now this router is ABR router, right? And if this router is ABR router, it will generate LSA 3. So IP ospf database. Router LSA of area 2. Which LSAs are? This is LSA 3 of area 2. It is advertising in area 10. LSA 3 of area 1. Which area 0? This one. Correct. Here is for area 0. LSA 3 for area 0. For area 1. Area 1, it is advertising these 10 subnets. From where the router is getting 10 subnets? Router 1 is advertising 10 subnets, and for 10 subnets, okay, 6, router 6, these ABR are generating this LSA 3, and these subnets for all 110 prefixes, router number 9 is generating LSA 3. Now this is not the way you will use in real time to extend the area 0. So say interface loopback 1 and no IP ospf 1 area 0. Here we need to configure now virtual link. So IP ospf interface brief. Done. Now I have removed the ospf configuration from loopback interface and so IP protocol. Now again this router is not ABR router. Fine. Yeah. This one. Yeah. Yes. Where is the network 110? This is router LSA of area 2. Here is the 110. Inter area prefixes. Inter area prefixes. No, no. For here are the external LSA, LSA 5. Right now, but now you can see router 9 is not ABR router. So what is the solution? Virtual link. So guys, see where is area 0 or which router is connected with area 0? Router number 6 and router number 7, right? So if I want to extend this area 0 till router number 9 till area 2, I have to create one virtual link either between router 6 and router number 9, or I can create a virtual link between router 7 and router 9. First, we'll create one virtual link and we'll advertise that virtual link in area 0. This is the concept. But to create the virtual link, always keep in mind, like between router number 6 and router number 2, between any two routers which are not directly connected with each other, if you want to configure the virtual link between two routers which are not directly connected with each other, in that scenario your requirement must be match, and requirement is there should be IP reachability. There should be IP reachability. Like on router number 6, I have one IP address. Let's suppose here on router number 6 on loopback 1, I am going to run one IP 6.6.6.6, and on router number 9 I have already one loopback where IP is 9.9.9.9. So to create the virtual link between 6.6.6 and 9.9.9, these both two IP addresses should be reachable with each other, right? So to make reachability between router 6 and router 9, means loopback interface of router 6 and router 9, what we can do, we see both routers are connected with common area, that is area 1. So if I will advertise 9.9.9 in area 1 and 6.6.6 in area 1, then both router will get these prefixes in form of LSA1, right? Router 9 will share this network to their neighbor to router number 8 in the form of LSA1. Router 8 will propagate it to router number 6. But router 6 will not propagate to router number 5 to their other neighbor, because this is LSA1. LSA1 cannot cross area. So first of all, let me try to make reachability between the loopback IP address which is running on router number 6 or on router number 7 and 9, router 9. So tell me, between which two routers you want to create virtual link, between router 6 and 9 or 7 and 9? 6 and 9 or 7 9? Both are same. Here on router number 9 and either on router number 6 and router number 7, because both routers are connected with area 0. Both routers are connected with area 0. Okay, so let me do one thing. On router number 6, I'm going to create one loopback, let's say interface loopback 1, and IP address 6.6.6.6.255.255.255 IP ospf1 area 1. I have advertised it in area 1. Then let me take you to router number 9, and on router number 9 we have already one loopback, interface loopback 1, say IP ospf1 area 1. So IP ospf interface brief, you can see ospf is enabled on loopback 1 interface in which area? In area 1. So now if you will check the router LSA of this router in area 1, so IP ospf database, then router LSA of 9.9.9.9. So this router have include this network 10 network in their LSA 1. Link connected to a stub network, means directly connected network. Now can I ping to 6.6.6 from here? Ping 6.6.6.6 and source 9.9.9.9. See, ping is working. In the BGP also, see, the all IGP protocols like ospf, EIGRP, RIP, these routing protocols can work with directly connected routers only. Like you can form ospf neighborship between router 8 and router 9. You can form ospf neighborship between router 6 and router 8, but you cannot form ospf neighborship between router 6 and router 9, right? Because these are not directly connected network. But in case of BGP, BGP is exterior gateway routing protocol. We can form BGP neighborship with directly connected devices also and with indirectly connected devices also. The requirement is IP reachability. There should be IP reachability. Both routers should be able to communicate with each other. Like on router number 6, I have one loopback 6.6.6, and here I have one loopback 9.9.9.9. So as these two IP addresses are reachable with each other, even now I can configure the BGP neighborship here. Right? I can configure the VPN over here. I can create the tunnel with the help of these two IP addresses. So for this is not the concept of virtual link. Now I am going to configure the virtual link. See, to configure virtual link, what command you need to run on router number 6? I can say router ospf, which area? Area 1, and area 1 virtual link to which router? To 9.9.9.9. Once I will hit enter, what will happen? This router will start sending unicast hello message to 9.9.9. So this is why there should be IP reachability. Done. And on router number 9, I am going to say virtual link router ospf 1, and then virtual link, sorry, area 1 virtual link, and the loopback IP address of router 6 is 6.6.6.6. Done. We don't have neighborship. Now you can see we have one neighborship on which interface? On ospf virtual link 0. This is just a name of virtual link. So IP ospf neighbor. Now you can see this router have one neighborship with 6.6.6 as well. Now router 9 have three neighbor, one router 10, one router 8, and one router 6. Getting my point, guys? And router 6 is connected with area 0. Router 6 is connected with area 0. Now you can assume like this, that there is one virtual link between router 6 and router 9. Fine. And the C interface. Interface is ospf virtual link 0. Done. Here on router number 6 also we can say so IP ospf neighbor. Here also you can see new neighbor 9.9.9. What is the difference between these neighborship and this neighbor? First of all, see, there is no any date time. There is no any date time. Correct? On router number 9 also you can see for 6.6.6 this date time. See the difference. Right? So on the virtual link, guys, there is no age. There is no age of LSA. These are what? Age of LSA. It is running one timer for LSA. After a specific predefined time, it will flush the entry. Right? So by default, routers are actually exchanging LSAs after a specific interval of time. But on the virtual link, router will only see a database once. Right? And as there is no date time, means router will never flush this entry. Router will never flush this entry. Whatever LSAs router 9 is going to learn from this neighbor, it will be for lifetime. So OSPF virtual link works on DND. Do note. And before that, one more thing. On router number 8, or sorry, on router number 9, if I will run command show IP protocol now, so now you can see this router is again ABR router, correct? This router is now again ABR. So if this router is ABR, then it will generate what? LSA. No, loopback is there, but loopback is in area 1 now. So IP ospf interface brief. Loopback is now in area 1, not in area 0. There is one virtual link now on this router, and that virtual link is in area 0. Getting my point? Yeah. Extending area 0. Now the router number 9 was not ABR earlier, so it was not generating LSA3. So if router 9 will not generate LSA3, then router 8, router 6, router 7, these routers will not get these prefixes 110. So that's why I have extended area 0 till router number 9 till area 2. So why I have created virtual link, guys? To extend the area 0. Right? And on the virtual link, whenever router will share LSA1 to this neighbor, so IPOSPF neighbor to this neighbor 6.6.6, it will set V bit on in their LSA1. Remember the bits, flag bits, B bit, E bit and E bit, V bit. These bits were there in the flag in the LSA1, right? So ABR router will on B bit, ESBR router will on E bit, and the OSPF router where virtual link exists will on V bit. And this time router 9 is ABR as well, so router 9 will on their B bit 1 as well as V bit on. E bit will be 0. This is how other router will came to know which one is the end point of virtual link, like router 8. When router 8 will receive LSA1 of router number 9, it will see, okay, V bit is on. That means router 9 is the end point of virtual link. And to verify this configuration, we can run command show IP ospf virtual link. So IP ospf virtual link. So see the virtual link configuration here. Run as demand circuit. Is there anyone who know the meaning of demand circuit? What is the meaning of demand circuit? Guys, any link which works on demand circuit will not send edge. LSA edge time. See, if I am sending one LSA to my neighbor and my edge time is 100 seconds, that means I am telling to my neighbor, bro, you can only carry this information for 100 seconds. After 100 seconds, you will flush this entry, right? But any link which is working on demand circuit will not set any edge time. By default, all routers are sending their LSAs with the edge time. So IP OSPF database. Are you able to see the edge here? Is here, is here. Yes, correct. And how to configure? See, not only the virtual link, even you can configure the physical link as well to work on demand circuit. I can say interface F 0/0. On router number 10 on F0/0 I can say IP ospf demand circuit. So what will happen after running this command? This router will start sending their LSAs from this link without edge time. Without edge time. Getting my point, guys? So this is the meaning of demand circuit. Demand circuit means DNA, not DND, DNA. DNA. DNA means demand circuit. Demand circuit means DNA. DNA stand for do not edge. Do not edge means this is one bit actually in the LSA. Do not edge. So router will set this bit on. Router will set this bit on. This is one bit in the LSA called DNA bit. Do not edge bit. And by default router sends their LSA with this bit off. Like by default all normal routers send their LSA with all bits, all flag bits off, but ABR router sends their LSA with B bit on. In the same way, any link which is running on demand circuit will set this bit on, DNA bit on. So router means router number 9. Whenever router 9 will advertise these prefixes in form of LSA 3 to 6.6.6 to their neighbor, what will happen? Router will on DNA bit in their LSAs, because virtual link run as demand circuit. And even I can show you that you can configure demand circuit on any other link also, right? By default on the virtual link it's work on demand circuit. So IP ospf virtual link again. Now see the rest configuration. It's work on demand circuit, then do not is LSA allowed, right? Transit area is area 1 means you have created the virtual link over which area? Over area 1. So actually I am exchanging LSA 3 over this area, over area 1, via which interface? Fast Ethernet 1/0. Cost to reach this neighbor is 2, right? Disable no, shutdown no. Then there are some more information. By default network type on the virtual link point to point. Hello time 10 second, dead time 10 second. These are exactly same. Hello due. Leave it for now. Now, so IP ospf database. See the database of router 9. Now it is generating LSA 3 for which area? For area 0. For area 0. And see how this router have, how router number 9 have learned these prefixes, guys. These prefixes from router number 6, right, in the form of LSA 1 or LSA 3, in the form of LSA 3, correct? So for all received dot you can check the edge. For all received dots you can check the edge here. Got it? Now on router number 5 we can check that router 5 is learning these partner 2 networks or not. partner 2 subnets or not. For that, let me access R5 and let me show you the routing table. So IP ospf database. See the ospf database here. There are some LSA3 and all 110 prefixes are there, right? And who is advertising? 9.9.9. 9.9.9.9 is ABR router. So it is advertising through the virtual link. That's why you can see edge time is not set here, right? Now it will install in it in the routing table. So IP route and 20.110.1.1.0 C dot is there via router number 6. In the same way, you can create virtual link between router 7 and router number 9 as well. Now my question is, will router 8 have these prefixes? Will router 8 have these prefixes, guys? Because in this scenario, here is virtual link. So router number 9 is going to generate LSA3. In their LSA3, it will include these all subnets, and then it will advertise to router number 6. It will advertise to their other neighbor as well, to router number 8 as well. Correct? Yeah. So now on router number 8 also you can verify the routing table, or you can check the database on router number 9. So IP ospf database. So IP ospf database. And then let's say I want to see only summary LSA. Okay, if I will run like this. Done. So we have these all LSA3, correct? Now can these two companies, partner companies, communicate with each other? Let me try. From the router number 10, I'm going to ping 20.1, ping 20.1.1.1, and source 110.1.1.1. Ping is not working. Ping is, guys, working, right? See, there is latency, right? There is some latency. It's taking some more time. On real devices, you will see the latency issue here, delay issues here, right? Sometimes packet loss here, because in this area all routers are managing all LSAs. Here also all routers are managing all number of LSAs. In area 0 also, even as area 0 is the headquarter, is the data center, definitely I can have high configuration routers here in this area. But what about this area? Like if partner network 1 and 2 want to communicate with each other, this is partner 1, partner 2. If these two partner companies want to communicate with each other, they have to communicate via branch 1. This is my branch 1. They have to communicate via branch 1 and headquarter. Right? So if these routers in area 1 are not high configuration router, then you have to filter the LSAs. Then again you can configure the NSSA area or the stub area. Clear, guys? So in the virtual link, I don't have anything else to teach you. For the security purpose, what you can do here, see, on the virtual link, router 9 is sending hello message and TTL value is 255 in the hello message. But as you know, there is only two hop between router 9 and router 6. only 2 hop, so you can configure TTL value 2. This is security feature, so that the hello message for the virtual link for the router number 6 cannot cross the boundary router, right? The boundary router, which is router number 6. So you can run one command here, and to read the output you can run verification command. So IP ospf virtual link on both router, on router number 6 also. So IP ospf, so IP ospf virtual link, this is one verification command. Then config t and router ospf 1 and say area 1 virtual link, and then I can say TTL virtual link, sorry, 9.9.9 IP address of router, neighbor router, and then I can say TTL security, right? So there are only 2 hop. If I will set 1 TTL value 1, then what will happen? If I will set TTL value 1, what will happen, guys? Will neighborship goes down? TTL 1, neighbor is down, because 9.9.9 is reachable via router number 8. So router 6 will send their hello message to router 8. On router number 8, TTL value will become 0, it will discard it, right? Whenever a router will receive packet, whenever router will receive a packet, it will check destination. If it will check destination, if destination is not router itself, then it is going to decrement TTL by 1, and if TTL value will become 0, then router will discard the packet. This is the default behavior of router, right? So yeah, go ahead. Between R6 and R2, where is R2? Here in the EAGRP domain. Bro, on router number 2 we are running EAGRPS number 10. How you can create the virtual link, and why you will create here virtual link? No, no, even you cannot configure. Virtual link is a concept of ospf. Here you are running EAGRP routing protocol, and I think you didn't get the reason, the main reason of virtual link, like why we are using virtual link. Let me do one thing, let me make one topology here again. Let's suppose, bro, I have some routers R1, R2, R3, R4. Done. Let's say this is my topology, and here I have one LAN network, and here I have one LAN network. See, try to understand. This is my router 1, R1, R2, R3, R4, R5. Here I have one subnet 10.1.1.0. Here I have one subnet 20.1.1.0. Suppose these routers are in area area 0. These routers are in area 1. and these routers are in area 2. So in this scenario, tell me, can 10 subnet communicate with 20 subnet? Can 10 subnet, can user from this network communicate with this user? No? Yes. But in this scenario, here is the ABR, na? Router 2 is ABR. So router 2 will generate LSA 3, right? To share area 0 prefix in area 1, right? But LSA 3 can not cross the area. So router 5 will not get 10 subnet. So the virtual concept of virtual link is extending area 0 here to here, right, between router 2 and router 4, as both routers are connected with area 1. So area 1 is my transit area for virtual link. Over area 1 I can create a virtual link, and that virtual link is in area 0. So now physically you can see router 4 is not connected with any area 0, but logically now router 4 is connected with area 0. So router 4 will become ABR now, and once router 4 will become ABR, it will generate LSA 3. It will generate LSA 3. In the LSA 3, it will include all prefixes like 10 prefix, and then it will advertise that in this area, in area 2. In the same way, ABR router will generate one more LSA for which area? For area 1, and then it will forward in that LSA 3, it will include 20 subnet, and then it will forward to this area, area 1. This is why we have virtual link concept. Virtual link is used to make communication between two regular area. By default, two regular area cannot communicate with each other, right? So real-time scenario can be, let's say this is my headquarter. In headquarter I am running ospf area 0. Headquarter is connected with one branch office, and in that branch office I am running area 1. And why we are running multiple areas here? Branch 1, area 1. What is the benefit of using area 1 in branch 1? Why not area 0? To reduce the database, right? If there are lots of router in single area, in area 0, then all routers are going to maintain full database, right? Full topology information. All routers are going to store full information of topology, right? So that's why here I have defined different area in branch office 1. And now let's suppose that my branch office 1 is connected with a partner company, right? Or any branch 2. Branch 2. Again, benefit of using different area between branch 1 and 2 is reducing database size. Let's say in the branch 1 there are 10 routers. All routers have 10 number of subnets. That means in their router LSA, in LSA 1 there will be 100 prefixes. Correct? In the same, in branch office 2 also I have 10 router, and all routers have 10 subnets. So in branch 2 also we have total 100 number of subnets in router LSA. And 10 routers are going to install 10 number of LSAs, and in each LSAs there are 100 number of prefixes. But if you are running same area in branch 1 and branch 2, then just assume how many LSAs, how many prefixes are there in LSA 1. First of all routers are going to maintain the full complete topology information, means all router will have 200 number of LSAs, LSA 1, right? And in the LSA 1 of every router there will be how many prefixes? 100 prefix plus 100 prefix, 200 prefixes, right? So database size will be very large. So that's why here I have divided the ospf network into area. In branch office 2, in branch 2 area is OSPF area is 2. Now tell me, can branch 2 communicate with headquarter? No, because there is no ABR order between branch 1 and branch 2, right? Now try to understand, branch 2 is part of two area 2 and area 1, and branch 1 edge router is also part of two area 1 and area 0. So as border router of branch 1 is connected with area 0, I can create one virtual link here between these two routers, and through that virtual link, these routers can generate LSA. It will exchange the LSAs, not LSAs, LSA3, summary LSA, right? And this is how headquarter will get branch office 2 prefixes. In the same way, branch office 2 will get area 0 prefixes. If there is no virtual link, then headquarter routers are going to generate LSA1. It will flood within the area, right? And this router is the ABR router. So this ABR router will propagate all network information of headquarter into branch office 1 and all prefixes of branch office 1 into headquarter. But between branch 1 and branch 2, there will be no route exchange, right? Whatever LSA3 this ABR router have generated in area 1, it will reach till this router, but this router will not propagate in this area because LSA3 cannot cross the area, right? This is why we have virtual link concept. Clear, bro? Now next topic is redistribution. So you already know what is redistribution. In EIGRP we have discussed it. Redistribution. Done. Redistribution is used to filter routes. But guys, try to understand the route exchange in OSPF. In EIGRP, how two routers exchange routes? With the help of update message? With the help of update message, yes or no? Both router 1 and router 2 are going to install all their routing table prefixes in their update message and it will share to their neighbor. So EIGRP share what? Network information. But OSPF share what? LSAs. And in the LSA, there will be address of router ID, right? So OSPF router does not share network information. OSPF router share link state information. So we cannot filter the route directly in OSPF like EIGRP. On the ABR router, ABR router is advertising route directly between two area. OSPF is also one distance vector routing protocol. It is not a link state routing protocol between areas, between different areas, right? So in the OSPF, you can filter route on ABR router only, right? Like in this scenario, if I want to filter, let's say see, router 1 is advertising these 10 prefixes to router number 5. I want to filter 10 prefixes on router number 5. Can I apply distribute list filtering in indirection? Will it work? To understand this, try to understand the route exchange in OSPF. How router 1 is going to advertise this network to router number 5? First, router 1 is going to create LSAs. LSA1. In the LSA1, it will carry these all information. And there will be LSA header. In the LSA header, there will be guys advertising router ID and link ID. Both will be the router ID of router who is advertising this LSA 1.1.1.1. Now let's suppose here on router number 5 you have applied the route filtering, right? You are denying 10.1.1.0/20 for subnet, correct? You are denying this subnet, right? In the ospf you have apply it under the distribute list. Now when router 5 will receive this LSA1 from router number 1, it will not filter the route, right? It will install it in their database. Router 5 will install it in their database, but while installing route in the routing table from the database, router will filter the route. While redistribution, first router will install all prefixes in their database. On the database it will run SPF algorithm, and with the help of SPF algorithm it will calculate best path and it will install best path in their routing table. So while installing route from the database to routing table, it will filter the route. So this time ACL will work, route filtering will work. But if I want to filter 10 prefixes in EIGRP, I can deny these prefixes in the odd direction as well. While I can configure the filtering on router number 1 in such a way so that whenever router 1 will advertise these 10 prefixes to router number 5, it will filter it. But in OSPF, filtering in odd direction over here will not work, right? Because while advertising routes, this time router is not directly advertising route, it is actually advertising LSA. It is advertising LSA. So always keep in mind OSPF filter routes while installing prefixes in routing table from the database, right? But if I will talk about the EIGRP between router 1 and router 5, let's say we are running EIGRP. So in EIGRP, if I will apply the filtering, what will happen? ONS router will receive the update message, right? ONS it will receive the update message. It will install all prefixes in their topology table. So while installing prefixes in topology table, it will filter the route, right? So this is the difference in case of OSPF and distance vector routing protocol in terms of route filtering. Clear? So let's say here I have a topology like this. This one is my topology R1, R2, and I have one more router here, R3. Here I am running OSPF routing protocol, OSPF. Here I am running EIGRP protocol, EIGRP. So router 2 is ESBR, EIGRP domain. And always keep in mind, routing protocols does not work on router. Routing protocols work on interfaces of router. Now router 1 have some network information like let's say 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24. So how router 1 is going to advertise these 10 prefixes to router number 2 with the help of EIGRP update message. Correct? With the help of EIGRP update message. In the update message, router 1 will share network information directly, right? So as EIGRP is sharing network information directly, we can apply the filtering in both direction, in direction as well as in odd direction. But OSPF does not send a routing table with neighbor, so we cannot apply distribute list in odd direction. By using distribute list, we are not filtering LSA, we are filtering the prefixes, routes, subnets. So only on a ESBR router we can apply filtering in the out direction, because see in this scenario what will happen when router 8 will advertise prefixes to router number 3, router 2 will advertise prefixes to router number 3. How it will advertise, guys? First of all, you will perform redistribution here, redistribute EAGRP into ospf, and let's suppose there is one filtering. In the filtering I am saying deny 10.1.0.0/16. So router 2 is going to install, see router 2 have first of all EAGRP topology table, EAGRP routing table, ospf database, and ospf routing table. So as we are performing redistribution on router number 2, router 2 will copy all routes from the EAGRP to database. So actually this time this router is copying route directly network information subnets. So here it will filter the subnet. Here it will filter the subnet. But if I will apply this filtering on router number 3, then what will happen? When it will perform filtering, guys, first router 2 have installed all EAGRP prefixes in ospf database, then it will calculate best path, and now router 2 have to advertise it with your neighbor. So which LSA it will generate? LSA 5 to advertise external prefixes. In LSA 5 it will install all external prefixes, then it will advertise to their neighbor to router number 3. Now router 3 have received what? Again LSA. So router 3 will install it in their database. So where is the filtering? You had filtering for 10 prefixes in the odd direction. Sorry, in the in direction. So here router have not filtered it, right? But while copying these routes in the routing table, it will perform what? Filtering. So let's suppose here I have one subnet that is 20.1.1.0/24, and here I am denying it, deny 20.1.1.0/24, and apply this route filtering in ospf. Now tell me, will R3 advertise 20 network to router number 2? Yes or no, guys? This filtering is in odd direction. In odd direction. Will it filter or not? No. The reason? See, once this network will come up in ospf, router 3 is going to add it in their LSA 1. In their LSA 1. And then it will advertise this LSA 1 with their neighbor directly. So it is not advertising route. So that's why it will not filter the route in odd direction here. Right? So on the ESBR you can apply filtering in odd direction, but on all the internal routers you have to apply filtering in direction only. In the in direction only. Now tell me how to perform route filtering here. Let's suppose on router number 5 I don't want to receive where is router 5? Here it is. So IP route ospf. See, through ospf I am learning all 10 subnets. These are intra-area prefixes, these are external prefixes, and these are inter-area prefixes. Let's suppose out of these prefixes I want to filter some prefixes. Let's say these 10 prefixes. These 10 prefixes, I want to filter these 10 prefixes on router number 5. How to filter it? Tell me, guys. Process is similar like EAGRP. I can create one access list to match the traffic. Access list number 10. Then deny 10.1.0.0.0.0. sorry, 0.0.255.255. Then access list number 10, permit any, rest all are permit. Now router ospf 1 and distribute list I'm going to call to ACL. Which ACL? Standard ACL, standard ACL, standard ACL number 10. Then in which direction you want to apply? In direction. On the internal routers we will only filter in direction. And then see, we have lots of option, right? I can apply this filtering on fast Ethernet 0/0. I can apply this filtering on all other devices, means on all interfaces. I can apply this filtering for a particular source. Port channel, everything is not for you. Applied. Clear IP ospf process. In the real time you will be not allowed to run this command, clear IP ospf process, because if I am running this command, see, ospf is breaking neighborship. Whenever router will break the neighborship, it will again form the neighborship. It will perform lots of encapsulation, decapsulation. It will create the database. It will generate the LSAs. It will run the SPF algorithm. It will calculate the routing table, right? Now, so IP route OSPF. Do we have 10 subnet here now? Do we have 10 subnet, guys? No, right? So IP route 10.1.1.0. Route is not in the table. Let me remove it. Router OSPF 1 and distribute list. Say no to this distribute list. Now let me take you to which router? Let's say router number 8. On router number 8, so IP route OSPF. And for now on router number 5 you can verify the routing table again. So IP route OSPF. So it is learning 10 prefixes again. Done. Now let me take you to R10. See, on R10, sorry, router number 8, R8. R8 is learning all 10 subnets from 2 neighbor, and it is performing what? Load balancing. Now guys, tell me how to perform route filtering to filter 10 prefixes from router number 7. I want to filter 10 prefixes from router number 7 only. I want to install these prefixes in my routing table via router number 6. Yeah. Tell me how to filter, how to perform the filtering. Just a minute. In the troubleshooting, guys, most of the time in real time you are going to troubleshoot the route filtering, because if two sides are not able to communicate, maybe there is route filtering applied, right? And route filtering is denying the main subnet because of your misconfiguration. If you don't have the a strong command on route filtering, you will configure the wrong scenario, right? Like instead of filtering 10 subnet from a particular neighbor from the router number 7, you can filter from the both side. Then connectivity will goes down, right? So you have to again practice route filtering. You can create the scenario. So on router number 8, what I can do, I can create one access list, same access list number 10, then deny which subnet 10.1.0.0 0.0.255.255 and access list number 10 permit any, then router ospf 1 distribute list number 10 direction in, and then on fast ethernet 1/1. So IP route ospf. Now you can see for 10 subnet it is not performing any load balancing, right? It is only learning 10 subnets from router number 6. Now if you are thinking, Praful, how router, when router 8 is filtering the route? So see guys, the very interesting thing. Route is not available in the routing table via router number 7. So IP ospf database, and this router 8 will learn 10 subnets in the form of which LSA? LSA 1, LSA 3, 5, LSA 3. So let me say summary LSA, and summary LSA of 6.6.6.6. Sorry, not summary LSA of 6.6.6. We can open the LSA with the help of link ID. So link ID 10.1.1.0. What happened? So IP ospf database. Okay, here also you can see in the database router have still LSA 3 from both neighbor, right? From both ABR, from router number 7 also, right? So LSA is still there. That means while copying route from the database to routing table, router have filtered the route. Router have filtered the route. So IP ospf database, and then we can say what here, summary link ID summary internal. Nope. Summary LSA, how to open the summary LSA in detail? Okay, actually here we cannot open the summary LSA in detail. Na? In the summary LSA it will only share the route information. We can open summary LSA in detail on router number 6 only. Like on router number 6, so IP ospf database summary and 10.1.1.0. Here also it's not showing the detailed information. These are the detailed information only. 2.0. So advertising router ID is there. Not able to see the link ID here. Okay, leave it. Maybe here we cannot run this command, right? So IP route ospf. Now it is not performing any load balancing. I have filtered the routes from a single AVR via AVR number 2. Now router ospf 1. Now guys, tell me the scenario how you want to filter the route. Tell me some scenario. See, first of all, if I will apply this distribute list in odd direction, what will happen? Distribute list number 10, and I am saying odd for all direction, means do not advertise prefixes which are matching in this access control list. And which prefixes are matching in this access control list? So access list 10, right? So IP route ospf, first of all it is performing load balancing, and now router 8 is going to advertise it with router number 9. So let me take you to router number 9. And on router number 9, so IP route ospf. Oh, actually we have here virtual link. Let me do one thing, say router ospf 1 area 1 virtual link 6.6.6.6. Say no. So IP ospf neighbor, done. So IP route ospf, now it is learning these prefixes from which neighbor? From router number 8. So IP ospf database. See the summary LSA. Summary LSA of area 0, summary LSA of area 1. So in the summary LSA of area 1, we are still able to see these 10 subnets. That means router 8 is not filtering, right? Router 8 is not filtering. So IP route ospf. So we cannot filter the route in odd direction on the internal routers of ospf. We can apply route filtering in odd direction on ESBR router, right? Like see, in this scenario, both ESBR router 3 and router 4, both ESBR are advertising 20 subnets. Both ESBR are advertising 20 subnets. My scenario, my requirement is router 3 means ESBR1 should advertise 2 subnet, 20.1.1.0 and 20.1.2.0 only, and router 4 should advertise the last subnet, which is 20.1.3.0. In which direction you will apply filtering? In direction or odd direction? If I am filtering route on ESBR, definitely I will apply it in odd direction, right? Or let's suppose this headquarter or branch office 1 and branch office 2 does not need to communicate with this department, the middle department with middle subnet. So I can advertise one subnet from this side and one subnet from this side. So let me take you here on router number 3. And router 4, and before that let me remove the filtering from router number 8 because it's not working. Router ospf 1 and distribute list, say no to this distribute list. On router number 3, guys, how to configure the ACL? Or I can configure the prefix list as well. Access list number 10 permit 20.1.1.0 0.0.0.255. Now router 3 will only allow this subnet, rest all subnets are denied. Like this, in the partner network 1 in AGRPS number 10, I can have 1000 number of prefixes, and let's suppose I want to only advertise 10 subnets, 10 prefixes. So we'll configure route filtering here. Got it? If I want to allow 2 prefix from the ASBR1, I can allow this one as well. And here I don't need to run deny command because by default implicit deny is already enabled. So router ospf 1, and now I can say distribute list access list number 10 and out. Done. Now let me take you to R1, and on router number 1 you can check the LSA5. So IP ospf database, there will be no any change in LSAs. On ESBR routers, but here you can see on the backbone router on router number 1, see 20.1.1.0 it is receiving from 3.3.3, 20.1.1.0 receiving from 4.4.4, same subnet from both neighbor, fine. 20.1.2.0 from both neighbor, fine. 10.1.3.0 from 4.4.4 only. It is not receiving this subnet 20.1.3.0 from both ESBR, right? Now I want that this ESBR, second ESBR should only advertise third subnet. So here I can say access list number 10 only permit 20.1.3.0 0.0.255 done, and router ospf 1 distribute list number 10 direction out. Now again let me take you to R1 and see the database again. LSA 5. See 3. ABR1 is advertising these two prefixes and ABR2 is advertising only this prefix. Now guys, let's suppose branch 1 users never communicate with partner 1 company, right? From here GRPS number 10, this company, this branch office never communicate with ES number 10. So what option I have? Can I apply filtering on router number 5 in odd direction? Tell me yes or no. Can I apply filtering on router number 5 in odd direction? Means do not advertise 20 prefixes to your neighbor, to router number 6 and router number 7. Nope. No. And if you will apply here filtering, let's say in the in direction, if you are not accepting these 20 subnets on router number 5, what will happen? Then definitely router 5 will not advertise it with their neighbor to router 6, router 7. Router 8 will not get these prefixes, as well as this company will also not get the prefixes. Now let's suppose I want to filter these 20 subnets only on router number 8. Only on router number 8. What we can do? If you will apply filtering in direction on router number 8, then router 8 will not advertise to router number 9 as well, right? For now, if you want to verify the connectivity between partner 1 and partner 2 network, what you can do, from the router number 10 you can ping 20.1.1.1 source 100.0.1.1.1. Will ping work? Ping is not working. Why ping is not working, guys? On router number 9, I think I have removed the virtual link configuration. Router ospf 1 area 1 and the virtual link 6.6.6.6. Again from the router number 10 I am going to ping. This time I am expecting ping should work. So IP route 20.1.1.0 route is not in the table. So IP ospf border router 9 is ABR router, that is fine. It will take some time. R9 so IP route 20.1.1.0. Now it have received the route. Now it should advertise with their neighbor, means to router number 10. So IP route, still route is not there in the table. So IP ospf database so IP route 20.1.1.0 Hmm? Route is in the database, but route is not in the routing table. So IP route ospf. There is no any external prefixes here in the routing table. What can be the issue, guys? If route is there in the database, but route is not in the routing table. So IP ospf database external 20.1.1.0 forward address is 0.0.0. That means my actual ASBR is generating this LSA5. Advertising router ID is 3.3.3, means router 3. Done. Mm -mm -mm -mm. So IP ospf border router. Now how to troubleshoot it? How to troubleshoot it? So IP ospf interface f0/0 0.2 point, and on router number 9 include network. Network type is fine. Just think what can be the issue. There is some misconfiguration somewhere. Because of that, earlier it was ping was working. See, for the route filtering here, what we can do on router number 8, let's say I want to filter 20.1.1.0. So I can create access list number 10 or access list number 20, deny or permit 20.1.1.0 0.0.255. Then say router ospf 1 and distance 255. Here I don't have option to call access control list from the source IP address 68.1.1.6 wildcard mask. Here I can call to access control list. See, if I will configure distance 255 like this, that means it will set distance 255 for all route. So IP route ospf. Now you can see there is no any route available in the routing table. Routers consider route with AD value 255 as unreachable. Right? If AD value is 255, that means that route is unreachable. So if you will configure AD value 255 in ospf, all routes will be automatically filtered. Right? But here I want to configure AD value 255 for access control list 20. So router ospf 1 and distance 255. I'm going to remove this command and now say distance 255 source IP address. What will be the source IP address? Let me set 61.1.1.6 from this source, and let me call to access control list 20. So IP route ospf for 20 subnet, it is still performing load balancing. That means my configuration is not working here, right? It is performing load balancing. router ospf1 distance 255 from 6.6.6.6 and access list 20. So IP route ospf. Clear IP route star. Let me refresh the routing table. So IP, this command is not working here, but like this you can set AD value 255 for some particular prefixes as well. Like this command is used to filter routes in a particular area, right? In a particular area. Like here in area 1 I cannot filter route with the help of distribute list, because if I will filter route with the help of distribute list in area 1, automatically route will be filtered in area 2 as well, correct? So we have this concept also. We can configure AD value 255, but it's not working. We'll see it in the next class. Router ospf1 distribute list and then see here I can call to access control list named ACL. I can call to prefix list as well as I can call to route map, right? So with the help of route map, can I filter 20.1.1.0 subnet? Route map, let's say Cisco deny sequence number 10. I am saying match IP address from list 20, right? Now it will match IP address from access list number 20. In access list number 20 we are allowing 20.1.1.0. Now let me try to apply this route map here. Router ospf1 and distribute list, then say route map, name of route map is Cisco and direction in. So IP route ospf, what happened? So access list, actually implicit, this is just because of implicit deny. Do so IP route ospf, there is no route, right? So I have to create same route map with permit statement with no match, so it will match all. Route map name Cisco, permit sequence number 20, and I am not going to match anything here, so it will match all. So IP route ospf, 10.20.1.1.0 is filtered. Let me try to filter single route with the help of distance value once again. For now, see on router number 8 I have filtered, so IP route ospf I have filtered 20.1.1.0 only, and automatically it will filter in partner network 2 as well, like on router number 9 also you can see. So IP route ospf 20.1.1.0 is there. How it is learning? How this router is learning this network? So IP ospf database, definitely it is learning through virtual link from their other neighbor. Router 9 have two neighbor na. So where is the 20 subnet, guys? See who is advertising 20.1.1.0? 3.3.3, 4.4.4. Let me open it in detail. External and 20.1.1.0. Forwarder address 0.0.0, matrix 10, advertising router ID is 3.3.3. Okay, actually here we have virtual link between router 6 and router 9. So IP ospf neighbor. So IP ospf virtual link. Why virtual link is this neighbor is up. In the guys simulation software like in GNS3 or even G, sometime you will get wrong output as well, right? Sometime you will get wrong output as well. Like on daughter number 1, I am not able to filter route with the help of distance value. Here the output is incorrect, I think. So IP ospf database. It is learning all 20 prefixes, that is fine from, but it should not learn this one 20.1.1.0 from the router number 8, because on router number 8 I have already filtered this route. Okay, let me try to filter this route over here. Router ospf 1, and here I am going to set distance value 255. From which neighbor it is learning this subnet? 20.1.1.0. What is the source IP address? 89.1.1.8. Access list. Yeah, just because of virtual link. Because of virtual link, it is learning the subnet, right? And here access this number 20. I'm saying permit 20.1.1.0 0.0.255. So IP ospf. So IP dot ospf tag So IP dot ospf. Still 20.1.1.0 is there in the table. Don't worry, we'll see it tomorrow. Tomorrow maybe we will have 1 hour session for the route filtering and 1 hour session for the what other topic is there guys in ospf. Default route propagation. So you have some concept that you need to learn in the default route. Otherwise I have, I think, already discussed the matrix type, route type. For the external prefixes, there are two types of metric and how to configure it. So we don't need to even discuss the default route propagation again. Like let's say router 10 is connected with internet. Router 10 is connected with internet. So on the router number 10 you are going to create one default route IP route 0.0.0 0.0.0 and exit interface is loopback 1. We cannot configure loopback 1 as exit interface, so say f0/0. Even it's working on loopback as well. So IP route include 0.0.0. So now you can see it have installed default route in the routing table. Now we need to advertise this default route in ospf domain, right? So that headquarter can also get this default route, branch office 1 can also get, partner 1 company can also get this default route information. So what we can do here, I can say router ospf 1 and default information originate, similar like EAGRP, default information originate. So this is the one option. Second option, here we can add the metric type. Here we can define the metric. Here I can add the tag value with the help of route map. So these are the features of default information originate. If you want, we will cover it tomorrow, right? Otherwise, this is very simple. You can perform by yourself as well. Okay, then after tomorrow we'll start BGP, the next routing protocol. Yeah, for the route filtering, I will design different topology. Okay, this topology is good to understand the LSS, and we have already covered LSS. So what I can do for route filtering, I will design any other topology. And guys, you can check the network company network design for ospf, and according to those design you can also perform the lab, like I can say real time network architecture for ospf protocol. So these are the designs where I am running, where I am using ospf. Like you can see, the backbone area is your headquarter, then you have some branch offices, right? And in the headquarter you have internet connectivity, means branch offices user will access internet via headquarter. I will share some design in your group, okay, for the ospf routing protocol. Like which routing protocol I will choose for my network, that also depends on topology type only, right? And which type of ospf network type I should configure, that also depends on topology type only. So everything depends on my design only, right? You all know the basic architecture of Cisco for network designing, like 2 tier, 3 tier, and for the data center, leaf and spine. Like if I have some access layer switches, some distribution layer switches, some core layer routers, and then internet. And here I have end devices. This can be what? One branch office. This is one branch office. Here also I can use ospf routing protocol, right? But generally between branches, like branch 1 and like this, I have multiple branch offices, right? And all are connected together. There is some data center, there's some headquarters, right? So between these companies, ospf network type is very important. You have to configure the ospf network type very carefully according to your requirement. And then according to your design you will decide the ospf areas, what ospf areas configuration will be there, right? Which branches will be in which areas. So first of all, after the planning, see, if I am planning to design a network for my company, first of all I will make one documentation for the requirement. Correct? What is my requirement? According to that requirement, I will plan for network designing, right? Then I will create the logical diagram. Then I will decide which routes I need to advertise from where, right? Which companies are going to communicate with each other, where I will take internet connectivity. Then according to the our requirement, right, according to our the connectivity, we will choose routing protocol, right? So first of all, you will enable the routing protocol here, like you can see in this scenario. First thing is definitely enabling ospf on all routers, and then the improvement. So route filtering or the distribute list, distance value, changing the distance value, these are the parts of improvement. Getting my point, guys? So first, perform basic lab like enable ospf between routers to make the reachabilities. And if you are good enough with enabling ospf between routers and all are able to communicate with each other, then start performing load filtering, if, apply the multiple areas there, right? So guys, I have one question for you. Tell me the answer tomorrow in the tomorrow class. And question is this: I have two companies network, two company A, company B. In company A, I have, let's say, 10 routers. In company B also I have 10 routers, right? So your question is, tell me the all benefit of putting these two company in different area over putting all routers, all these two company in the single area, right? Like enabling ospf area 0 on all routers. This is one scenario, scenario first. Second scenario, enabling ospf area 0, let's say in company A, and area 1 in company B. So the benefit over here, okay, you guys can google, you guys can use wikipedia, right, to check why we come up with area concept. Done.